we have been talking about the four main components of functions, and so far we looked at the function name, we've looked at arguments. Now it's time to look at the body of the function. The function body is typically a script. That is, it's a series of R lines with R functions and objects that will perform a particular task. The function body can be a method call. Methods are functions that are associated with a particular class of object. What this means is that some of the functions that are written by people who have a lot of experience with R might do different things depending upon what kind of object is used when the function is called. These are called methods. They're associated with the class of the object. Let's look at the body of the function for mean. What is in the mean function? Well, you might expect that you're going to see that it sums up a bunch of values and then divides by how many values there are in the vector. But in fact, the body of the mean looks like this. One line. That one line says use method mean. When we use the mean function, it's actually calling another function called use method with a mean argument. This tells me that the mean function has different methods. Let's look. These are the methods for the mean function. We have mean.date, mean.default, mean.difftime, and so forth. There are various functions that our mean function can call depending on the type of object we send to the mean. Obviously, you and I, when we think of the mean, we think of sending a bunch of numbers. You add them up, you divide by how many there are. What's so hard about that? But in fact, in R, the mean function can do a variety of things, even when we don't send it numbers. The use method function will look at the type of object we sent and then determine which mean function to call. Now, when our object is either numeric or logical, it's going to call mean default, mean.default. So that is the mean function that we normally think of. Although we don't actually see mean.default, all we have to do is type in mean. The use methods function will determine whether we sent a bunch of numbers. If it did, it will then call mean.default. Mean.default looks like this. Now this is more like it. Now we have something that looks more like a script. If I look at this particular script, it's really doing three things. First, it's checking to make sure that when mean.default was called, it contained either numeric, complex, or logical data, which is the type of data it needs in order to be able to perform the normal mean function. If it gets something different, if it has a different type of object, then it's going to stop and it's going to give a warning that this is not the right kind of object to be given to mean.default. The next piece down here says, if the na.rm argument, remember that? If it's set to true, then remove all the missing data. And that's what this next line right here does, is it removes all the missing data. The next part of this says, if trim is set to something other than 0, then trim the data, and all of this trims the data. That's what this is all about. So really you have, starting up here, you have a check to see if you're sending the right kind of object to mean.default. Next, you're seeing if the Missing values should be eliminated, and if so, they are. And next, you're seeing if the data should be trimmed, and if it should be trimmed, then it's being trimmed. But what about calculating the mean? When all of this stuff is done so that we end up with a value of x, you see that little x here? Once we end up with a vector that has exactly what we're asking for, missing removed if we ask for missing removed, trim if we ask for trim, we've already checked that it's the right kind of data so that the mean function can be used, then the actual mean is calculated, and that's done right here. Now you might wonder, well, can we look at that? No, we can't. The dot internal tells me that this mean function was not written in R. It was probably written in another language called C. The reason is that some languages can be optimized to be faster than R would be. And so by writing in that language and creating it as an internal function in the R program, anytime this mean is called, it's faster than it would be if it was written in R. This is commonly done with functions that are used a lot. If they're not used a lot, the R programmers don't worry about that. But if they're used a lot, then it might be written in another language. Before we get to the mean call, all this is written in R. But once we get done with that and then do the actual calculation of the mean, adding up the numbers and dividing by how many there are, that's done in code that's been written in another language. Well, what we saw was mean.default. That's what we've been looking at. That's the kind of mean we're used to. But remember that the mean had other methods. So let's look at one of those. Here I'm going to enter a date. Look at this, as date. That means there's an object called date. So I'm going to enter the date for Valentine's Day, and then I'm going to enter the date for St. Patrick's Day. If I look at the class of one of those, you see the class is date. So there are other objects we haven't talked about that are less commonly used, but if we were doing an advanced course, we would talk about these. But now notice what happens. If I combine Valentine's Day and St. Patrick's Day into a vector, so now let's look at that. Both dates. There's the two dates. I can actually send this to the mean. And look at what it does. It finds me halfway in between those two dates that I just entered. You can get a mean of your dates. Now this did not call mean.default. If we look back at the methods for mean, notice that there's one called mean.date. That's a different script. So the idea here is that we can use the mean function, but when we send the mean function our argument, that is when we put in an object, what the mean function will do is call used methods to determine which of these different methods should be used to calculate the mean. So the mean goes beyond what we think of as the mean. Okay, now the function mean has a method for dates, and it finds the middle date. We saw that. There are other methods for the mean, but we're going to stop here after having looked at both the default method and also a method for working with dates. But now let's go back to thinking about those three dots. Why those three dots? Let's look at the arguments that are listed for the mean. What? The only thing that's listed is an object and then three dots. Well, what about the trim? What about the NRA.rm down that I saw down here? Notice that that was for the default method, the mean.default. But if you look up here, the general mean only has one argument, object. But if the object happens to be a number, a vector of numbers, then mean.default is called with these additional possible arguments. So think about that a moment. The arguments for mean.default, let's look at those. The arguments for mean.default include trim and NA.rm. But the first thing that we call whenever we type in mean is not mean.default. The first thing we call is the mean function. And then if we've got the right kind of vector, then it will call mean.default. So what happens when I want to put in my data and I want to trim part of my data and I want to remove everything? What happens when I send that? Now you see the reason for 3 dots. The mean function will accept my data and won't do anything with these other values, these other arguments. It won't do anything with the trim and NA.rm except once it determines from my data that it's numeric and that it needs to call mean.default, it will now pass these through to mean.default. So the original function with its 3 dots has object and the 3 dots, meaning pass through. And why? Because we might be passing through to another function that needs this information. So that's the reason for the 3 dots. The fourth and final function component is the return value. That is, what is actually returned from the function. This is not required. Some functions don't return anything. They just do something. But most functions will return a value. So let's look at what's returned when we send a numeric vector, my data, to mean. Let's store it in my data mean, and let's look at the class. The class of my data mean is numeric. So the mean function, because we gave it a numeric vector, returned a numeric vector. Now, the numeric vector that it returned is a vector of length 1. It's a scalar, but a scalar is a vector of length 1. So it's a numeric vector that was returned. The return value of a function is important to know because if we're not getting back the same kind of object we thought we were getting, it can, in fact, create problems later on in our script. The function components are function name, arguments, which are not required, the function body, and the return value.